Hi, I'm Jeeun. I'm from CU Boulder. I'm local. So if you have any question about the Colorado or Convention Center, please ask me. I was gonna present the future of fabrication. We call HFI, Human-Fabrication Machine Interactions, to imagine the machines as a co-designer. This work comes from the collaboration among CU Boulder, Meiji University, and University of Toronto. As most of the people sitting in this room already agree, there has been huge advances in the robot assistance. For example, in the industrial setting where the robotic arm helps the fabricating the parts, and in the education where the robot teaches or sometimes just plays with the children. Or in the hospital where the robotic arm take the medical surgery, and even the household robotics are becoming popular. And they show great harmony. Should I move my... Okay. Oh. And I hope someone in this room is super excited about this. For this a bit. So they collaborate, they interact, and the robot understands the human, and they try to interact with each other. They are not just a simple robot, they are collaborators, they are interactor, they are assistants of a human. I'm gonna stop it here. No. It's a little hard to... Am I right? Am I at the right arrow? Maybe this works better. Okay. So how about the fabrication? I'm taking the fabrication machine as one type of robot because even if that has a limited degrees of freedom, it can help a designer to complete their task, and they are delegated some kind of the human's work, and they try to collaborate and interact. For example, a 3D printer and the laser cutter and the CNC miler. Before we think about the designer and the collaborative machine agents in the creative process, even the human and human already collaborating each other. Here, one designer completes the brief sketches about their entire masterpiece. Then another designer as an agent who helps filling the colors and completes the details to make a balance of the entire artwork. Let's remind of the creative process, because the creative process is where I am valuing and where we can take the importance of handwork and the improvisation simply set aside it. Because the beauty of handwork, beauty of the creative work comes from the human's dexterity, who plays with the materials, who plays with the tools, hand tools to deal with those materials, and some kind of improvisation from the effects they get from the materiality and the tools they are utilizing in the creative process. Again, here, human's dexterity touches the materials and play with the materials. So if we are taking the human hand tools and the materiality as an agent itself in the creative process, we can think about the collaborating and interacting with the materials, and probably as a fabrication machine as a collaborate agent. But unfortunately, here, current fabrication machines or fabrication robots does not support this iterative process of the improvisation. They usually work alone. They just execute whatever programmed by the designer at the 2D-based screen. They don't compromise the results, even if the designer make a bad decision at the design time, which has been already done at the the virtual design, there's nothing they can do while the 3D printer is operated, and there is no way to go back to the scratch and then modify the design. Yes, there is a fabrication machine or a robot, which looks like collaborating with the designer, but the most part of them are just simple replication of the designer. So we can say that they are collaborating and interacting to complete the entire piece of work together. Let's take a look at the 3D printing as one process of fabrication as an example of why this happens. There is a gap between the virtual design and the physical design. So designer completes their design at the design tools and conduct their design actions. And if that goes to the physical fabrication process task, that phase, there is a gap between the virtual design and the physical design. There is nothing user can do while the 3D printer is operated. So the intelligence information always comes from the human to robot, the machine, never comes back from machine to human. Here I represented again the current fabrication pipeline limits the designer's fabrication design space into that gray area because that black boxed production loop is hindered by machine and from the designer side. So they can conduct any kinds of design action, model, and conduct some modification. But if they set the printer job, they have to leave and maybe come back for the post-processing. Here the iteration becomes essential because if they find the failure, they should go back to the third design, and they might create another gap between the second third design to the physical outcome. So we propose a human-fabrication machine interaction, which changes that black box into the loop, so designer can physically intervene the printing process, and they can update their design minds. They can redesign, rethink about the new design with the design mind changes comes along the process, and the robot, the fabrication machine as an agent robot, understand what those intentions were, what those physical actions were, and then compromise the results and try to mitigate the probable negative impacts to the final outcome. And then they can finish the entire process at one go, and they, as a designer, can participate in the entire fabrication process. So here's my overarching question. In a designer and the fabricator collaboration, can a fabricator collaboratively work with a designer? Can they proactively inform, sometimes guide what is the better design decision in situ, and probably simulate the possible aftermath from their huge computational power and the precise simulation? Or can they lively guide the humans to compromise their design mind from that is transformed from the initial design thinking? And can a human be directed by a robot assistance? So in this HFI process, we change the domain of the material. So not only the physical material, the designer can utilize the design thinking, which comes into the process, and the materiality and the machine parameters that changes the fine details of material. And the intersection of these generates the partial outcomes, which feeds back to the next step for the creative process. So step by step, the designer can complete their final outcomes with their improvisation and beauty of handwork. So there are 3 design goals. This physical intervention should be accessible enough, so the designer should not lose the control of the creative process, and this process should be fluid enough, and of course, it should be concurrent. So here's the question that I want to ask to all of you and invite you to the discussion. So what information does a human want to know from the robots in a collaborative creative process? And what could be the best way of communication? There has been some kind of method like showing faces over the screen and showing the gaze towards a human, probably some digitized information through the LCD panel or the sound alerts. But as you intuitively imagine, they are not enough information during the creative process if you want to take a robot assistance as a replacement of the human collaborator. So in this paper, we proposed a speculative scenario to imagine the future of fabrication. Maybe you can use the AR device that is the video cue of the 3D printer's brain. So you can show the preview of the future movement of the 3D printer, and then maybe you can assign the future movements to the 3D printer or the fabrication machine directly. Or you can make the fabrication machine more intelligent and smarter to understand your embodied and tangible gestures. And so we can make the perception, that you as a designer is collaborating with the fabrication machine in real time. So we hope we can make the designer go just out of the lab where the physical machine is there. So they can brainstorm with the nature and the material they found from there, and then reflect their design from those designs, and they can reflect those into with their controllable devices. Here we got a great review from one of reviewers that we could think about the crowd-powered 3D printer. If a user is collaborating with only one 3D printer, then that 3D printer might not be smart enough because it has a lack of knowledge. But if that connects to the cloud, we can share all the knowledge stacked from all different 3D printer. Then you can download all the information, why the 3D printing failed and what could be done better design decision for the designer. So the designer can utilize all idea from the internet, which is not yet belongs to that one user. Okay, here we propose a human fabrication machine interaction, but this middle part can be anything. Fabrication robots, fabrication process, problem in materials, and sometimes have fabrication zombies so that you can control the walking dead body to control them to complete your creative process with them. Thank you, I'm happy to take a question.
Hi, Paul from the University of British Columbia. I wonder if you might be able to speak a little bit more about the dynamics of control. I thought it was an interesting point that you said, just about how much you want to control the process as a creative person. I think about when you do 3D printing or something like that. You can't really control the middle of the process, but you can control the beginning of the process.
Yeah.
And then when I collaborate with somebody, though, I can't control what they do at all.
Right.
And that's actually part of the beauty of it.
Yeah.
Yeah.
So that's why we propose the machine as a co-designer. They are not just simple agents. We want to empathize others' understanding and want to utilize they can do better and what we can do, we as a human can do better. Yeah. Great point, thank you.
Okay, I think that the agent technology has more power to users, so I feel
to do so. So we want to utilize that into the process.
okay.
Yeah, there's a lot of possibility. I want to listen about that too.